Hello everyone. At this moment, I will be presenting to you how to calculate for moles. Last time we discussed about the definition of moles. We were also able to know what is molar mass and how we calculate for molar mass. And so at this moment or at this juncture, let me present to you how do we calculate for moles of a particular compound or element that is embedded or present in a particular compound. Now, in order for us to calculate for mole, we make use of this formula. We have here the number of moles in a sample is equal to the mass of an element or compound, which should be in grams unit, divided by molar mass, which should have grams per mole na unit. So again, in order to calculate for the moles, we just simply divide the mass of an element or compound in grams divided by the molar mass, no, which has a unit of grams per mole. Now, there are two ways, class, by which we can calculate for mole. It's either we will look at the whole compound, or it's either we will consider a specific element that is present in a whole compound or in a larger compound. So, if we are tasked to calculate for the mole in a whole compound, it only means nga ang mole sa whole compound ang atong tan-awon. Now, naapoy sample problems, class, or mga solving later on nga we are required to get the mole of a specific element that is embedded in a larger compound. And we can also do that, which also requires a different process, no? Pero same na good gihapon siya with how we calculate the whole compound. Naalala siya mga ipang tweak or ipang add na mga ratios later on sa last step. So now let us consider first this problem. So we are calculating moles in a whole compound. So in this case, we are tasked to determine the mole for a whole compound. So we have here the problem, as you can see. How many moles are in 42.5 grams of NH3, or that's ammonia? So, ang given natin here is the mass of NH3, which is 42.5 grams, and we are required to calculate for the mole of NH3. So, this is a whole compound. Wala man tagi pa-specify or wala man siya ni-specify nga specific element nga naa sa NH3. Like, ang i-calculate nato is the mole of NH3. Like, whole compound, gives siya ang tipok nga compound. So, the formula that we will use is number of moles equals mass divided by the molar mass. And don't forget the unit. So, we just exchange the value for each variable here. For each variable here. So for number of moles, this is equal to 42.5 gram of ammonia, as you can see. So I place 42.5 grams NH3 here because this is where we should write down the mass of our compound. So this is the mass of the compound, and then divided by its molar mass. And so one thing that we should remember, class, in calculating for mole is we need to make sure that every data that we need for us to carry out the formula, or for us to implement, or to follow the formula are there. So dapat na atong mga data. So in this case, the molar mass for ammonia is not given, and so what I did here was that I calculated for molar mass. And, di ba, kabalo naman tanong sa pag-calculate sa molar mass. We just multiply the number of atoms for that element by its molar mass, and then we add everything, and that's where you can get the molar mass for that particular compound. So, I just, ano bang tawag dito? I just place here the molar mass because this is where molar mass should be written, no? Dapat naa siya sa baba. So, the mass, which is in grams, and then the molar mass, which should be in grams per mole. Now, this is how we calculate the number of mole, no, of this particular ammonia. So, we cancel out the unit grams, kaya mag-cancel out pa na sila because na siya sa numerator, na po siya sa denominator. And, of course, dapat ma-cancel out yun siya kaya we are after man sa unit nga mole. So, if we will cancel out this gram here, ang mahabilin na unit is mole. So, in other words, there are 2.50 mole of ammonia and 42.5 grams of ammonia. So this is our answer. Now, always remember that in writing your final answer, you need to make sure that you follow the number of significant figure. So, as you can see here, there are 3 significant figure given. Like the values here have 3 significant figure, which is the reason why our answer has also 3 significant figure. And then the mole na unit. So that's how we calculate for the mole of a whole compound. We look at the mass of that compound, and then we divide it by its molar mass. Then we cancel out the same unit, and what's left there is the mole. And then the values. Then we make sure na yung significant figure are reflected. So kung ano yung significant figure na nasa given, yun din yung makikita dapat sa final answer. Like in this case, isa raman ka value or like kiniramang mass ang naa, wala may other variables for this. So, mo ito nga kinipud atong gipasihan for the final answer. So, I hope that you get the idea, no, of how we calculate for the mole of a whole compound. So now, we have here another problem set. So we need to find now the amount of the indicated element in moles. So we have here number 1, 8.75 gram of boron trioxide. And number 2, we have 333 milligrams of calcium oxalate. Now this sample problem here, class, is different from the previous one because in the previous one, we look at the whole compound. The question itself did not direct us to determine the mole of a specific element. Okay? But then, in this case, dito sa sample problem nga itong nakita, we are instructed to determine the number of moles of this specific element here. Like in the case for number 1, we need to look at the mole for boron. Then for number 2, we need to look at the mole for carbon dioxide. And so, how shall we do it? So the same process with how we calculate the mole, gamit gyapon ta atong formula nga mass divided by the molar mass. Then at the end, we will figure out or we will calculate the ratio of the mole of this particular element with that of the whole compound. Okay? And so let me walk you through how we can calculate the mole of a particular element. As so say for example, our first problem, we are tasked to calculate the mole for boron. And this is the mass. So as you can see here, this is the mass of the whole compound. It's 8.75 grams. And then we were not given with molar mass, and so what we did was we calculate for molar mass. So yung given natin is the mass, and then we are required to determine the mole of boron. So for the molar mass of this whole compound, the boron trioxide, we have here this value. And please don't forget, class, to always write the unit for molar mass. Dapat makita yung grams per mole nga label. Because in other words, if you can see this one, like we have 69.64131 grams per mole. So in an easier explanation of this, in every 1 mole class of this boron trioxide, there is a 69.64131 grams. So mao na siya ang pasabot gid ana nga for every mole mo ni ang iyang equivalent na mass or grams, no? So unsa na to siya pag-calculate? Now in this case, wala na ko ni diretso dito sa katong formula nga mass divided by the molar mass. So ang akong gibuhat nga class is this one. So, diri makita naman ninyo no, giunsa dyan ako ang whole process. Pero ako lang mong i-walk through giunsa na to pagkuha ang final answer. And so, in this case, on the left side, as you can see there, I write 8.75 grams of boron trioxide as my numerator, then over 1 as my denominator. Now, I did this in order to make this value here as ano bang tawag doon? Fraction, like in a fraction form, kaya para dili gid malibog. Pero anyways, pwede ra gud gyapon class nga wala oning 1, so whole number ang mapabilin diri like ang 8.75 grams tapos times 1 mole of boron trioxide over 69.64131 grams of B2O3. So, unsa man ni ma'am nganong ingani man? Okay. So, ingani ang pasabot ana. Di ba on this side here sa left, this is the mass of the boron trioxide. And if iingani na to ang forma niya class, this is just a ratio man good class kanang ratio ra jud ni mga calculations sa mole. So for this one, kailangan na to ma-cancel out ng grams of boron trioxide. Mauna nga atong gisulat diri sa denominator sa other variable is 69.64131 grams of boron trioxide, which is also its molar mass. Tapos ang atong numerator is the mole. Kaya di ba dili na ta magsulat diri a class of 69.64131 grams per mole of B2O3 because ang mole ibutang na nato siya sa top diri sa numerator. So in other words, for every 1 mole of B2O3, there is a 69.64131 grams of B2O3. So ingana ang ilang ratio. So, ingani po ang iyang plastada, kay lagi, our main goal is to cancel out the unit na grams of boron trioxide. So, if ingani una to siya, makancel out ni siya nga unit, and what's left here will be the mole of B2O3. Now, we don't stop there, kasi nga, if di-ari lang tama na atong calculation class, ang makalculate nato nga mole ani is for the whole compound. Now, since we are directed to get the mole of the boron nga element, we still need to add another step for that or another ratio on that. So in this case, di ba, nakita man gud ninyo nga siya nanay pula. Pero in a way, if wala pa tanay procedure wala man ni siya, di pa man ni siya ma-crash out or ma-cancel out. So napaning mole of B2O3. So in this case, since we are asked to determine for the mole of the element nga boron, now we will look at how many moles of boron are there in this formula, this chemical formula that is given. So as you can see here, class, for every 1 mole of B2O3, there is 2 mole of boron. Now, where did I get 2? I get that number because, as you can see here, there are 2 atoms of boron that is joined or that is connected with oxygen. Kaya makita na to nga na ay 2, o basta kay naana, di ba, na discuss man na ko siya last time, nga tanaw na to pila ka book atom ang naa. So sa case sa boron, naa siya 2 ka atom, which is why I place the 2 mole of boron in the numerator, and then the denominator is 1 mole of B2O3. Now this is their ratio, like ingani ang ilang equivalent. So you may wonder, ingana man ma'am, di ba pwede nga ma-interchange sila? Nga ang 2 mole of boron kay ibutang na to there sa denominator, and ang 1 mole of boron trioxide will be at the numerator? The answer there is no. Dapat dili sila mag-interchange because our main target class is to cancel out the units from the other side and then from the ones nga naa-put diri sa atong variable, because our main goal man gud is to only retain the needed unit. So here I place 1 mole of B2O3 as my denominator, and by doing this I can now cancel out the unit nga mole B2O3, which is still naapa ni siya sa numerator sa other variable. So if you will arrange it this way, ma-cancel out ning mole of B2O3, and what's left now is the 2 mole of boron. So that's how we can get the mole of a particular compound. Kaya di ba kung diri lang tataman class, this is only intended for getting the mole of the whole compound. But since we are required man to get the mole of a specific element, so we need to determine pila ka mole of that particular element ang naa sa chemical formula. And in this case, for every 1 mole of B2O3, there are 2 mole of boron. So cancel out the unneeded units, and what's left will be the mole of boron. So if you will plug it in your calculator, 8.75 times 1 times 2 divided by 69.64131, you will get an answer of 0.251. Okay, so this is, I think, the round off na nako ni siya, and I use 3 significant figure because based on the given, the value there has only 3 significant figure, which should or which must reflect put here sa ako ang final answer. So my final answer for this problem is 0.251 mole of boron. So in other words, in 8.75 grams of boron trioxide, there are 0.251 mole of boron. So that's how you will interpret your answer. Now, what about this second sample problem? So we have here 333 milligram of calcium oxalate. So sa may buhato na to, ana. Okay. Diba class, in calculating the number of moles, diba, number of moles that is equal to mass, which should be in grams, divided by the molar mass, which should reflect the unit grams per mole. So in this case, our given is 333 milligram of calcium oxalate. Since milligram man ni siya, dapat i-convert nato ni siya into grams. And we can convert this value by multiplying to the conversion unit, no? So we have here 333 milligrams times 1 grams over 1,000 milligram. So, diba, for every 1 gram, there is 1,000 milligrams. So, for this one, the milligram unit will cancel out. So, 333 times 1 divided by 1,000, and that's where you get 0.33 grams. Or you can just move class the decimal places 3, or the decimal place 3, so na 3 place to the left. Like, katulo siya, like 1, 2, 3, pa left man siya, kaya there are 3 zeros. And so, you can get now this value nga 0.333 grams. So, we've now converted this 333 milligram into grams. Then, since the number of molar mass for this compound calcium oxalate was not given, I also calculated here. So I just determine the number of atoms for each element, and then I multiply it with its molar mass. Then I add all of the atomic masses. Then I arrive at this answer, and I also don't forget the label. Okay, so the same process with the first sample problem nga niagi ta og katong mga ratio na, katong mga ratio sa molar mass, and then katong ratio sa mole for the element and the compound. Ang na-add lang jud diri a class is ato lang siya gi-convert pa from milligram to grams. So here we have, so this is how we usually convert, no? Or we calculate the mole of a particular compound that is embedded in the mole of a particular element that is embedded in a larger compound. So here, we are given naman already with the mass. So we have 0.333 grams of calcium oxalate over 1 times 1 mole of calcium oxalate over 128.10028 grams of calcium oxalate. So, diba sa numerator, makita na ito nga ang unit is grams of calcium oxalate. Now, that's on the left variable. Now, for this variable class, we need to make sure nga ang unit nga grams will be placed at the denominator para ma-cancel out siya. Okay, dili man ta after nga ma-determine ang grams. We are after of the mole man of the specific element nga carbon. So, here, ang pasabot ani, for every 1 mole of calcium oxalate, there is 128.128 grams. Kaya diba that's like kanang tinamban gani nga pagsabot nato class for the molar mass. Nga in every 1 mole of that compound, mo na ang iyang grams nga equivalent. Okay? So here, ni-reflect siya nga for every 1 mole of calcium oxalate, ani ang grams na makuha nato. So, i-cancel out nato ang unit nga grams, and what's left now is the unit nga mole. Mole of calcium oxalate. So now, we will also need to cancel out the unit nga mole of calcium oxalate, which is why I place the 1 mole of calcium oxalate here at the denominator kay para ma-cancel out gyud sila. The other side, the unit is on the numerator of the other variable, then the other one is in the denominator of the other variable kaya para mag-cancel out ang ilahang unit. And as you can see there, by just looking at the chemical formula, for every 1 mole of calcium oxalate, there are 2 moles of carbon. No? Like, dapat hawd lang gyud ta class mo sabot gani sa ratio nga pila ka buok ing ani ang naa ani nga compound, pila ka grams, pila ka moles, ana siya. So in here, for every 1 mole of calcium oxalate, there are 2 moles of carbon. And since this unit here will cancel out with each other, since naa siya, ga-exist siya sa other variable, so the unit that will remain out from this calculation is the mole of carbon. And if you will multiply 0.333 times 1 times 2 divided by 128.128, you'll get an answer of 0.00520. Okay, mole of carbon. So in other words, for every 333 milligrams of calcium oxalate, there are 0.00520 mole of carbon. Now, as you can see here in the final answer, there are 3 significant figures because in the given, napod siya 3 significant figure. Okay? So that's how easy, class, you can calculate the value of the mole of a specific element that is present in a larger compound or present in the whole compound itself. Now, there are also cases, class, wherein we can determine the mass of a particular element in a compound by just looking at the mole. So, naato yung mga problem set later on nga we will be instructed to calculate for the mass of this element by just considering the number of moles that is given. Moles and molar mass, kana sila. Dapat naana sila. Or dapat ma-determine na nato para makakalculate sa mass sa isa ka particular nga element. Okay? So say for example, this is just a practice, no? Like how do we calculate for the mass of a particular element by just using the molar mass and the mole. So here we have the question, what is the mass in grams of sodium, which has a molar mass of 22.99 grams per mole, and 25.0 grams of sodium sulfate, which has a molar mass of 142.0 grams per mole. So, ang pangutana, class, nag-revolve around pila daw ang timbang in grams sa sodium nga naay 22.9 grams per mole. This is its molar mass. And 25.0 gram of sodium sulfate, which is the whole compound, which has also 142.0 grams per mole. So, ang saan mo na ito na siya pag-calculate. So, yung anila siya kasayon. Now, dapat i-write down na to ang given. Kaya para mag-guided kita nga, ay mo ni siya ang given, mo ni ang naa, mo ni ang mga values nga pwede na ito magamit. So, for this problem, we have 3 data that are given, no? And this will be very helpful for us to calculate for the mass in grams of this sodium. So we have here 22.9 grams per mole of sodium. So this is the molar mass of sodium. And then we also have 25.0 gram of sodium sulfate. So this is the mass in grams of the sodium sulfate. Like, naanay mass class itself ang sodium sulfate. Pero ang gusto lang nato may balan is out from this 25.0 gram of sodium sulfate, pila pud ka grams of sodium ang naa. So, you know what I mean? Kana siya. And then, we also have here the molar mass for the compound sodium sulfate, which is 142.0 grams per mole. So the required here, class, is to calculate the mass in grams of, or the mass of sodium in grams nga unit. Okay, so unsa mo na to siya, ma'am? Alright, so yan siya kasayon. So we will still utilize the previous steps that you've learned in calculating for mole, specifically for the whole compound, and for a specific element. So here, we write here 25.0 grams of sodium sulfate times 1 mole of sodium sulfate divided by its molar mass, which is 142.0 grams of sodium sulfate. So, kini siya, class, mo ni akong giikong kaganina nga, kining 25.0 or kani siya nga variable here, kining mass, pwede na siya butangan og 1, pwede po nga dili. Okay? Kaya itong main goal mo dira is to cancel out the grams per, cancel out the unit nga grams. Now, you may question, pwede ba ma-interchange? Like, kining 1 mole of sodium sulfate, ibutang na to siya diri nga side, siya ang maguna over 142. Pwede rin siya ingana if mole lang ato ang i-calculate for the whole compound. But to avoid kalibog, no? We will just arrange our formula like this. Nga ang mass, which should be in grams, will be divided by the molar mass. Kaya if ato guni siyang itinamban, class, kini magud siya kay ang pasabutan ni if ingani na to siya forma kay it's like the mass of the compound divided by its molar mass. No? Kay for every 1 mole of sodium sulfate mango, there is a 142 grams. No? So, dili na ta magbutang diri sa kanang label nga grams per mole. Kay lagi ang mole, ibutang na to diri sa numerator. Kaya itong target mango is to cancel out the unit nga grams. Okay? So, in this arrangement, so dapat na sa first step, we divide the mass of the compound by its molar mass. And then we cancel out the same unit on the other variable and on this variable. So what's left now is the unit nga mole. So now, we need to look at how many moles of sodium are there in the chemical formula. And as you can see here, class, in every 1 mole of sodium sulfate, there are 2 moles of sodium ions. So, ingani man ang iyang plastada. Now, gingani na to siya pag-plaster, kaya atong main goal, class, is to cancel out this unit nga 1 mole nga nasubra dito sa other variable. Naa sa numerator. So, dapat ang pagplastada po na to ani sa mole sa sodium sulfate is dapat naa siya sa denominator kaya para makancel out sila. And what's left now is the 2 mole of sodium ions. Now, if diri lang tama ng atong calculation, like diri lang sa ratio of the mole of the element that is present in the compound, ang atong makuha lang, or if we will just stop here, ang atong makuha ang answer, class, will be the mole of a specific element. But since we are asked to to determine the mass in grams of sodium, we need to add another step. So in this case, so di ba, na-cancel out naman yung grams of sodium sulfate, na-cancel out na yung mole of sodium sulfate. And what's left now is the mole of sodium. Now, this is where the logic will come in for the molar mass of this element of interest. So here we are given class, ang molar mass for sodium is 22.9 grams per mole. And this would be very easy now since given naman siya, pero pwede na good gyapon i-check nato sa periodic table if wala gani siya sa problem. And so in this case, since naapamaning unit nga mole of sodium, dapat ma-cancel out ni siya. Now we can do that if we will place mole of sodium here as our denominator, and our numerator is the grams or the mass of the sodium. So, magunganong ingani man, ingani ang iyang forma. Because class, we are after of the mass of the sodium in grams, and if we will arrange it this way, then we will cancel out those units that are unneeded, and what's left will be the grams. So here, this is just a ratio nga for every 1 mole of sodium, there are 22.9 grams of sodium. So since napamatay balance diri class nga, wala na cancel nga unit, which is mole of sodium. So if ingani una to siya pag-plus star, ang mole of sodium, like 1 mole of sodium nasa denominator and numerator is ang mass niya, we can now cancel out the unit nga mole. And then, we will retain the value 22.99 grams here. 22.99 grams of sodium. And so, we will just plug it in our calculator, or, ato ipang sulat siya sa calculator. So, we can have like 25.0 times 1 times 2 times 22.99 divided by 142.0 grams. And you will get an answer of 8.10 grams of sodium. So always bear in mind lang yun class nga, in calculating for grams, dapat ang mahabiling gyud nga unit ana niya is ang gram itself. Grams itself. Dapat ma-cancel out yung mga unneeded na mga unit. So if, di ba balikon nato ang ato ang na-learn so far for mole. Now, if diri alang taman class ang atong calculation, you can get the mole of the compound. And if paabto na to siya diri ang steps wherein we determine the ratio of the compound with that specific element of interest, ang makuha na to diri is the mole of the specific element. Now, if we will add the ratio of the molar mass of that particular element of interest, then over 1 mole. So this is where you can now get or determine the mass of that particular element. So from here, we have 3 significant figure. So we have 8.10 grams of sodium. Now, nga tulo man ka significant figure? It's because, based on the rule for mathematics and division, we need to select which among of the values involved contain the least number of significant figure. And in this case, our least significant figure, this is 22.99 ha, nakulangan og 9. Our least significant figure here is this 25.0, which is 3 lang. And this is the reason nga nung tulo ra pod ka significant figure ang naa. So, we can justify nga out from this problem, there are 8.10 grams of sodium in every 25 grams of sodium sulfate. Okay, I hope that I have delivered to you very well the steps in calculating for moles, specifically in the whole compound, or for calculating the moles of the whole compound for a particular element that is present in a whole compound, and for determining the mass of a particular element that is present in a compound. Alright? So, if you have questions and clarifications, class, please don't hesitate to ask. You can just email me, you can just approach me face-to-face later on. If you have points to, or if you have concepts or kanang mga things that are not clear in your end, you can just ask me. And you can also read the materials that I have uploaded in the LMS. So I have given you there, I have uploaded actually a book reference for this. And you can also go to YouTube. No, there are a lot of examples there as to how you can further strengthen your skills on calculating the moles of a whole compound, of a particular element, and even in determining the mass of a particular element that is present in a whole compound. Now, as part of your assignment, I want you to calculate the mole of the following. So we have here two sets of problem. For number 1, I want you to calculate the mole of this whole compound, sodium bicarbonate. And then for number 2, I want you to calculate the mole for oxygen in this following numbers here. So this is sodium borate, kining number 2. So for number 1, ang process nga inyong i-follow ani is kadtong how we calculate the mole for a whole compound. And then for number 2, ang process nga inyong sundon ani is kadtong how we calculate the mole of a particular element that is present in a whole compound. So alright, so thank you so much everyone for listening, and I hope you guys learn, and please do everything to learn about these calculations, because I have given you my best naman good class. So kamo na po ang pag-effort, no? Saan siya nga para mas may balaan pag yun ninyo. Okay? Pero if namoy pangutana, ayaw jud ka ulang nga ma-approach sa ako, or mo email sa ako, or mo send sa ako og message. Okay? So thank you so much, and may God bless us all.